Hello everyone, this is my final project for CompSci 6570 Data at Scale. My project is a proposal for a longitudinal consumer finance data store. First, some background on financial struggle in America. 38 million Americans live in poverty. A third cannot cover a $400 emergency expense, and 2/3 feel they are not on track to retire. According to the CFPB, a third of Americans have low financial well-being. Financial well-being can be thought of as a person's level of financial security and the resulting freedom of choice. Some factors have an obvious effect on financial well-being, like income, amount in savings, and net worth, but other factors don't have as clear an effect. Examples of those factors are unexpected expenses, denial for credit, high interest loans, home purchases, and credit delinquencies. So how do we measure the effects of factors like these? Current data sources on the topic of financial well-being include surveys performed by the CFPB and the Fed. But these data are cross-sectional because individuals are not tracked over any period of time. Using cross-sectional data, correlations can be found. For example, credit denial may be correlated with lower financial well-being, but causality cannot be determined. For example, changes in financial well-being as a result of credit denial are impossible to identify. So there is a need for longitudinal data to determine how different factors and financial decisions affect financial well-being in the future. Longitudinal consumer financial data could be compiled by combining historic credit report data, data from financial institutions, and other sources that would provide data points of interest, like tax records and property records. This data would be warehoused in a wide column database. This central repository could then be used for multiple applications, like traditional statistical analysis or serving a consumer-facing app in the future. One proposed use of the data warehouse would be translating the data into a graph database where relationships between events, financial decisions, and financial health metrics can be explored. This would support research on relationships that could be leveraged through government regulation and consumer education programs to improve financial well-being of Americans. One primary source that would be used to compile the data store is historic credit reports. Credit reports would contain data elements like employers, credit accounts, credit score, and delinquencies. The second primary source is financial institutions. This data would include data on consumers' asset accounts, transactions, and credit applications. Other sources that could supplement this data are vital records, bankruptcy records, tax records, military records, and education records. Here's the data presented in an entity relationship schema. Consumer is the central entity with attributes that describe a person. The consumer entity has a key attribute that identifies each individual person. Other entities encapsulate elements related to financial information like credit reports and accounts. Some entities like credit report and application are weak entities because they are only identifiable by the consumer to which they belong. It would be possible to use a relational database to store this data. Using this method, tables would be created for each entity and primary keys and foreign keys would be used to link each entity. However, there are some scale considerations. There are 260 million adults in the US and each person has on average 5.3 accounts. There would also be trillions of transactions, so the size of the database would be very large with trillions of records. Flexibility must also be taken into account. The data would come from many different sources like different credit bureaus and banks. It would be very time intensive to fit the heterogeneous data into a rigid relational schema. Because of the need for high scalability and flexibility, a relational database is not ideal. Instead of a relational database, a wide column database is recommended. Wide column databases are capable of storing huge volumes of data with faster querying speeds than a relational system. Wide column databases are also very flexible because rows do not have to have the same columns. This would make the task of storing heterogeneous data much easier. In a wide column database, the data would be stored in column families rather than tables. Here is a conceptual outline of some of the column families that would be in the database. A consumer column family and credit report column family would use the consumer ID as the row key. Column families like account and transaction would use the consumer ID and the account number as a composite row key. One big benefit of a wide column database is time-stamped values. This would allow for storing the historic financial data three-dimensionally across rows, columns, and time. Here's a conceptual visualization of how this would work. In this example, each of a person's historic credit reports are stored in one row. The data elements from the credit report have timestamps corresponding to the date of the credit report. In terms of data storage, a distributed system could be used. However, distributed systems require a large initial capital expenditure. Because this project would need to be funded by grants, this is not ideal. Cloud solutions are customizable in scale and storage, much like distributed systems, but have a fee-for-service pricing model. This would avoid the large capital expenditure of a distributed system. So cloud storage is recommended for this database. Quickly to discuss the CAP theorem. The initial purpose is research, so lack of availability and partition tolerance could both be tolerated. And since historic data will be used initially, consistency is also not a priority. The database should then be designed with consideration for future uses. Future uses may include streaming data from credit bureaus and financial institutions and also developing a consumer-facing app. And so an AP architecture should be used. Availability would be important so the data sources have constant write access and users of the app can always access the app. Partition tolerance is important so that availability wouldn't be lost due to network partitions, and eventual consistency would be sufficient because users of the app wouldn't expect instantaneous changes to be reflected because other similar finance apps don't do that. Once the data is compiled, it could be translated into a graph database. This would help researchers to generate hypotheses on how financial events affect financial well-being metrics. In the graph database, consumer nodes would represent a person at a specific point in time, and other nodes would represent financial events like new cards and loans, real estate purchases, delinquencies, bankruptcies, and credit denials. Here's an example of what a home purchase would look like in the graph database. The consumer here sent a loan application to a bank, which then issued a mortgage to finance the purchase of a property. One end result is a warehouse of longitudinal consumer financial data. This could be used for traditional statistical analysis as well as serving a consumer app in the future. The graph database would further support relationship-based research on how events and decisions affect financial well-being. The graph database could also be used in the future to generate recommendations for how consumers could improve their financial situations. To demonstrate the use of the graph database, here's an example of one consumer in the perspective graph with time on the x-axis. You can see that a person's financial history becomes more comprehensive when presented this way. It's also easy to see how trends could emerge and be used as a basis for hypothesis testing. The result of the analysis made possible by this solution has the potential to be transformative. Lenders that are associated with drops in financial well-being metrics could be subjected to tighter regulations, and predatory lenders could be identified and shut down. Consumer financial education could be transformed with evidence-based information on how events and decisions affect financial health. Government incentive programs could be established or expanded to incentivize decisions that improve financial health. And personalized recommendations could be given to consumers to help them improve their financial situations. As far as alternative approaches go, a relational database could be used, but like I mentioned, performance would be an issue due to the size, and storing heterogeneous data would be difficult in a rigid relational schema. A document database would be a valid approach because they are also very flexible and scalable. But wide column databases are typically better for warehousing data, which is one of the goals, and a document database would also get very complex with the time element that's involved. A key value store wouldn't be a good fit for this application because the data is too complex. Rapid retrieval is not needed in the initial use, but could be used in the future as part of a consumer app to persist data in memory. The warehousing phase could also be skipped, and a graph database could be built directly from the source data. but a warehouse would be useful for traditional statistical analysis and serving a consumer app in the future. Also, warehousing first would ease the task of translating into a graph database because the data would be given a more consistent structure to work with. Lastly, tools like MapReduce could be used for transforming data and during analytics, but speed is not of the essence in any of the initial phases, so MapReduce would be unnecessary. In the future, it could be used for things like aggregating information in the consumer app. So, in summary, many Americans face perpetual financial struggle. Analytics could be used to ease financial stresses. Analytics could be used to guide government decisions on program funding and lender regulation, transform consumer education, and enable personalized recommendations for people to improve their financial situations. But currently, the necessary data for such outcomes does not exist. So the data must be compiled in a new database solution using historic credit report data and data from financial institutions and other sources. Doing so would enable new knowledge generation on how factors affect financial well-being. This has the potential to improve lives and lower financial stresses for millions of Americans. These are my references, and thank you all very much for watching.